Well, not if they're not appropriate. Okay? Sine of 2 theta equals 2 sine theta cosine theta. So this one you have to memorize. 2 sine theta cosine theta. Because we have seen this come up a lot. This is the most common double angle formula. And it comes up in calculus all the time. Emily asked me yesterday where the angle addition formulas come from, and you have to use geometry and figure it out. These are very easy to derive, okay? So, like the way you would derive this is you would say this is equal to the sine of 2 theta is equal to the sine of theta plus theta. You don't have to know this, but I'm just showing you, right? Which you could use the angle addition formula to get sine theta, cosine theta, right? Plus cosine theta, sine theta, cosine theta, sine theta, which is 2 sine theta, cosine theta, right? That's where that formula comes from. It's from using the addition formula, because if I add these two things together, that's what I get, okay? But that's where that formula comes from, but you don't have to derive it at this point, okay? But this formula does come up a lot, and you will have to use it, and you don't want to use the double, you don't want to have to derive it every time. So just memorize it, okay? Cosine of 2 theta is equal to, if you did this with your if you did this using the summation formula for cosine, for if you did cosine theta plus cosine theta, or cosine theta plus theta, you'd get cosine squared theta minus sine squared theta, okay? Which is also equal to, if you were to plug in 1 minus sine squared in for cosine squared, you would get this formula. 1 minus 2 sine squared theta. Okay? If you were to plug in 1 minus sine squared. So that's another form of the double angle formula for cosine. And the other form of it is 2 cosine squared theta minus 1. So depending on what you're given, you could always use any one of them, but like if you're given the cosine of an angle only, you would probably want to use this formula. If you're given the sine of an angle only, you want to use this formula. If you're given both, it doesn't matter which one. You can use this one or that one. Then for the tangent of 2 theta, if I were to take theta plus theta and plug it in for the angle addition formula for tangent, I would come up with 2 tangent theta over 1 minus tan squared theta. Okay? And so those are the double angle formulas that we will give you everything except for the one for sine of 2 theta on the test. But if you forget it, you could derive it pretty quickly, hopefully. Okay? So how do you use this? Use this with problems like if they said, I'm going to do it over here so I can have another. So what if they said solve 2 cosine x, 2 cosine x plus sine 2x equals 0. Okay?
Not sine squared x?
No, not sine squared x, sine 2x. So what a lot of you guys did on the test and stuff, you wanted to divide that by 2 to get rid of this. You can't do that. You can't divide this because it's attached. Sine is a function. So you can't just divide away the 2. But what you can do is rewrite this as 2 cosine x, and then using the sine 2x formula, or 2 theta, 2x in this case, you would get 2 sine x cosine x. I'm trying to squeeze it. I guess I can move over. 2 sine x cosine x equals 0. Questions on what I did there? Okay. Now I can factor something from both of these. What comes out of both of these things? There's a 2 and there's a cosine x, right? So I could factor out a 2 cosine x from this expression as well as this expression, and I get 1 plus cosine x equals 0. Oops, 1 plus sine x, thank you. Yeah, 1 plus sine x equals 0. And then I draw my little squiggly line. And I see there 2 cosine x equals 0, which would mean that cosine x equals 0. When is cosine x equal to 0? At pi over 2. And then again at 3 pi over 2. So if I was solving between 0 and 2 pi, I would get those two answers, right? If I wanted all answers, I would say plus 2 pi k, right? And then where is sine of x equal to negative 1? Sine of x is equal to negative 1 also at 3 pi over 2, right? So because these two answers are the same, this one and this one, you don't have to write them twice. You just write these two answers are your answers, pi and 3 pi over 2. Okay? Right? You don't have to write 3 pi over 2 twice. Was that confusing, Delaney?
Wait, it's actually, isn't it pi over 2? I don't know how you have cosine.
What?
It's pi over 2.
Oh, sorry. Mr. Leader, it's dumb. Okay. Thank you, Manny. Cosine of x is equal to 0 at pi over 2 and 3 pi over 2. Not pi and 3 pi. Okay. Sine of x equals negative 1 at 3 pi over 2. I messed up. Are you focusing here?
Yes.
Okay. It's okay. I know, me neither. So, what if I want to do for the same thing? Oh no. So let's do one where they say something like this. I'm going to jump ahead. I use a green pen because I'm tired of this color. Cosine of theta equals 5/13, and theta is between 3 pi over 2 and 2 pi. Okay? And they want you to find sine of 2 theta and tangent of 2 theta. Find. Could you do that?
Maybe.
Okay. Hey, I'm moving to check up on you kids who aren't doing good. So for this one, I'm going to use, so probably what it's useful to do is draw a picture. Which quadrant would I be in? See, it says theta is between 3 pi over 2 and 2 pi, so that means you draw a picture over here. And you know that cosine is 5/13, so what would this side be? Well, you call it negative 12 because its y goes down there, right? So sine would be negative over there. Yes? Good. And so sine of 2 theta, you're just going to plug into the formula. Sine 2 sine of theta cosine theta, because you don't know what the sine of 2 theta is. Well, you know what the sine of theta and the cosine of theta is. And you plug into the formula. 2 sine of theta is negative 12 over 13. And cosine of theta is 5/13. They give you that. And then you multiply everything together, and you get the answer. 2 times negative 60 over 169, which is equal to negative 120 over 169.
Could you do that again?
What? Slower.
Yes.
Okay.
Wait, where do you start with the T?
So I'm trying to find sine of 2 theta, right? The formula for sine of 2 theta is this, yes? Right?
Correct.
Okay. So they give me cosine of theta is 5/13, and they give me theta is an angle in the fourth quadrant, right? And so I can draw the triangle where cosine is adjacent over hypotenuse. I can do the Pythagorean theorem, find this side, and it's negative, cosine is negative there. And then I just look at this picture for theta, right? This is theta. So 2 theta, that would be, I don't know, you go around the circle that much, and then again that much. Maybe I'm in the 3rd quadrant, maybe I'm in the 4th quadrant, I'm not sure where I am, but I know that the sine of 2 times that angle is equal to this. So either it'd have to be in the third or fourth quadrant because it's negative, right?
Not necessarily. If it's a big enough angle, it's all around. That's true.
Well, yeah, but if the sine of the angle is negative, then you have to be in either here or here. Okay? Okay. What?
That's the second part.
There's a second part. Okay? Oh, I forgot to do tan of 2 theta. Tan of 2 theta is 2 tan theta over 1 minus tan squared theta, right? Over 1 minus tan squared theta, okay? And so if I want this, I have to look at this picture again. What is the tangent of theta? Right, negative 12 over 5, and 1 minus tan squared theta is negative 12. You have to be careful with your signs here, okay? This becomes, right, you have to square this, which becomes positive, and then you subtract it from 1, right? So using some math skills that you should have, 2 times negative 12 is negative 24 over 25, or not over 25, over 5. And on the bottom I have 1 minus 144 over 25. You with me there?
Plus.
1, no,
Oh, I see.
because it's minus, minus, which makes plus. Okay. Thanks. Okay. And then, so you with me? Okay. And then I have negative 24 over 5. And this is like, I could write this as 25 25ths, 1, right? When I subtract, I think that's negative 119. Because 25 minus 144, that whole thing over 25. And then I copy dot flip, so I get negative 24 over 5 dot flip 25 over negative 119. And then negatives go away, right? Negative, negative. And you can turn that into a 5 like that. And you get 5 times 24, which is 120 over 119. Okay? Kind of fun to do fractions. Okay. Now I'm going to tell you my joke, but I have to pause, otherwise I'll get in trouble. Okay? I told you. Okay. Okay, so now we're going to go on to the half angle formulas. These you don't have to memorize, but you will have to know how to use them. Half angle formulas. Okay, and these look like this. The sine of u over 2. Sine, that's a sine. My ends look kind of funny. The sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u over 2. Okay? And these are derived from using the double angle formulas. Okay? And the cosine of u over 2 is very similar. It's equal to plus or minus the square root of 1 plus cosine u over 2. And the tangent of u over 2 is equal to 1 minus cosine u over sine u, or this is also equal to sine u over 1 plus cosine u. If you were to multiply by the conjugate of the top, you could come up with those two versions of the formula. So these come out of the double angle formulas, and then taking the square root. And anyway, so how do you use these? Okay, so you see how there's a plus and a minus there. Okay, choose the key is, and this is where people get confused, choose the positive or negative sign. That's S-I-G-N, right? Positive, negative, depending on the sign of u over 2. And I'll show you what I mean in a second. Okay?
So S-I-G-N?
S-I-G-N, like whether it's positive or negative. Okay? Yes? You know what's really sad is that I tell jokes so much. Last night I had a dream that I made up a joke. and it was actually, I kind of laughed about it in the morning, but then I said it's a really stupid joke. So,
We need to hear
so there's this lady who works here. Here, I have to pause, okay? Anyway, so that maybe because I teach about science and cosine. So you use this if you want to do like find the cosine of 105 degrees. Find the cosine of 105 degrees. So if there is an angle that you don't know how to find the sine or cosine of, but you know that twice that angle is something that you do know how to find the sine or cosine of, that's when you use the half angle formula. What's twice 105? 210. So so if I say that u over 2, okay, is equal to 1 over 5, that must mean that u is equal to what? Twice that, which is 210 degrees. So I don't know the sine or cosine of this. Doesn't matter because that's not part of the formula. For the formula uses u, not u over 2. You see? Now I could have also used the addition formula. I could have said this is 16 and 45 and done it that way and got an equivalent answer. But in some cases it's more convenient, or they want you to just use the half angle formula instead. Okay, so if I were doing this, u over 2 equals 105 degrees. So which quadrant is 105 degrees in? It's in the second quadrant, okay? Is cosine negative or positive in the second quadrant? Negative. So when I use this formula, which is the formula that I'm going to use, I'm going to take the negative part of that formula. See? Okay? Because u over 2 is negative in the second quadrant. Okay, that's how you know whether to use positive. Not where u is negative or positive, but where u over 2 is negative or positive. So then I just plug into the formula, and I get cosine of 105 is equal to negative the square root of 1 plus the cosine of u, which is 210, which you know the cosine of, over 2. And then the hard part is simplifying this, right? So this is equal to negative square root of 1. What's the cosine of 210? Very good. You guys are good. Equals 1 minus root of 3 over 2, because cosine is negative, this would be in the third quadrant, right? And you're talking about this angle being 30 degrees. So that's plus negative root of 3 over 2 over 2. You with me there, Delaney? Yes? Okay. So now I have to do some, so if you left it like this, and you said there, I'm done, and depending on what kind of mood I'm in, I'll either take off 1 point or I will let it go, okay? But really you should try to simplify these, okay? And the way you simplify this, because it's kind of fun to do it. Whoa. That's why I don't like the movie where sometimes it's, okay? Anyway, it's easier if I look this way. So I'm going to find a common denominator and rewrite the top as 2 minus root of 3, that whole thing on over 2. And there's still this square root, goes all the way down, over 2 over 1. Do you guys see what I did? Okay. I just found a common denominator of the top. So I multiplied this 1 by 2 over 2. And that's equal to the square root of 2 minus root of 3 over what? If I copy dot flip, what do I get on the bottom? 4. And now I don't know if you know this or not. You should from algebra way back. Whoops, I forgot about my minus sign, right? Minus sign in front. If I remember this from algebra, this is equal to 2 minus root of 3. And you could take that square root of 4 completely out of the square root symbol and write it like that. And that's your best answer in simplified form. Negative square root of 2 minus root of 3, the whole thing over 2. Which is kind of weird because you have a square root inside a square root. But that's the simplified answer. Okay?
Oh.
Yeah, I just square rooted the bottom and left the top alone, right? The square root of 9 over the square root of 3 is equal to the square root of 9/3 or something, right? So you can break square roots apart. You can multiply and divide square roots. You just can't have them. So that's how that works. Okay? Questions? Tangent works similarly. I'll let you look at the examples. But there is one more that I want to do. No more? One more. Okay? Yay, Luke wants one more. Okay? We're going to use plain paper. So, solve. Find solutions. So this means find all the solutions from 0 to 2 pi, meaning once around the unit circle, of this funny looking equation. 1 plus cosine squared x equals 2 cosine squared of x over 2. And you say this looks really scary and horrible and all that kind of stuff. Anyone know where to start?
Well, you'd have to find the down below.
You don't have to. Go ahead, Charlotte. What?
Well, isn't 1 plus cosine squared sine?
Yeah, but you don't want to mess with that, I don't think. Cosine squared. What you want to do is write this as equals. This is like, this here is the same as saying this. Right? That's what that is. It's just different notation of writing the same thing. So how can I write cosine of x over 2? Plus or minus, right? It's times plus or minus the square root of 1 plus cosine x over 2. See what I just did? I just plugged into the formula for the cosine of x over 2. Now I'm going to square it. What's nice about that is it doesn't matter if this is negative or positive, right? When I square it, because when I square it, negative times a negative is a positive, and positive times a positive is a positive. So I get 1 cosine squared x equals 2. This is not plus or minus, right? I'm just showing you that this could be a plus or minus, so it's times. Square root goes away. 1 plus cosine x over 2. Now what goes away? The 2's. You can cross out this 2 and that 2. What? Because I squared it. When you square a square root, it makes the square root go away. Oh, sorry. Square. Sorry. That's why you got confused. Okay? Because this is a formula for cosine of x over 2. I square it, the 2's go away. I can rewrite this as 1 plus cosine squared x equals 1 plus cosine x. Now I can cancel out a 1 from both sides, can I?
It doesn't work.
What? You're up.
Oh, wait,
I'm not done yet. Okay. I can't just divide away a cosine x. I have to subtract it. So I get cosine squared x minus cosine x equals what?
0.
0. And now I factor that to cosine x times what? Cosine x minus 1 equals 0. And then I draw a little squiggly line. Whoops. Ooh, let's try a different color. How about this green color? Ooh, that's really good. That's frog green. Okay? So we get cosine x equals 0, or cosine x equals 1, right? Where is cosine equal to 0? Pi over 2 and 3 pi over 2 and 3 pi over 2. Where is cosine equal to 1? At 0. Not at 2 pi because we have a curving line, right? So we only go from and including 0 to 2 pi, not including 2 pi. So these are my three answers between 0 and 2 pi. Okay? 3 pi over 2, pi over 2, and 0. And that's all. Yes, sir.
You have to do this for all the stuff you can see, like, from 1 plus 2 actually equals more or less.